derivative of bonds. Convexity is the second derivative. The first concept in bonds is duration. The second order, the concept is convexity. The convexity is a measure of the curvature. Curvature means the second derivative, curvature, or the degree of the curve, the relationship between bond price and bond yield. Convexity demonstrates how the duration of a bond changes as the interest rate changes. I mean, it looks at the relationship between the duration of the, how the duration of the bond changes in relation to the interest rate changes, in relation to the yield. But for the managers of different companies who are managing the portfolio will use this convexity as the risk management tool to measure and manage the portfolio's exposure to interest rate risk. The portfolio manager can take this particular convexity as the risk management tool to find out the interest rate changes. Now, price and yield are inverse related, that all of us know. The price the bond with a greater convexity increase more when the yield falls and declines more and declines less when the yield rises. Look at convexity of bond A is 12.14. Convexity of bond B is 10.94, for example. The bond A has got more convexity than bond B. Now, the price of bond A increases more when the yield falls. So when the yield is falling, the price increases. So the bond with the higher convexity will have a greater impact. That particular price will increase more than bond B. At the same time, price of bond A declines less when the yield rises compared to bond B. When the yield is declining, when the yield is, for example, increasing, the price of bond declines less. So, as a bond portfolio manager, he has to keep the higher convexity bonds in his portfolio than the lower convexity bonds, because when the yield is declining, he will get more price. When the yield is rising, the impact will be less. The price decrease will be less. So the bond B with the low convexity, the bond B convexity is 10.4. The bond B with the low convexity, whose price does not fluctuate much when the interest rate changes. So that doesn't have much fluctuations. So it is nothing but the company's stock price, which does not fluctuate much. So, for example, pharmaceutical company, the FMCG companies, those companies' stock price will not change much. So, it is the same way. So, the bonds with the low convexity bonds will not have much price fluctuations. Whenever there is a bond price increase, yield increases, or yield falls, that such type of bonds will not fluctuate much. Whereas the high risky stocks, for example, the stock which is having more than beta 1, which is having higher fluctuation with regard to price. The same way, bonds with the higher convexity will have a greater fluctuations. I mean, just comparing bonds with the stocks. Hope the theory all of you understood. Theory part. So convexity, we look at the relationship between the interest rate changes and with a duration. Okay, so the bond portfolio manager should have more of high convexity bonds. So if you have got more high convexity bonds, so you will his portfolio is exposed to higher interest rate changes. So what he has to do, he has to mix both high convexity bonds as well as low convexity bonds. You should not have only the high convexity bonds. She's asking a question. Yeah, she's asking a doubt with regard to the immunization, W into 10 plus 1 minus WX into 13.5 is equal to 13. 13 is the duration. Yes, correct. 13 is the duration of the particular insurance policy. Insurance policy. 13 is correct. Yeah, correct. Correct. What you said is right. Yeah. Now, how do we compute this? Look at the equation. Sigma T square plus T into CT divided by 1 plus YT whole divided by P into 1 plus Y square. Sigma T square means the time period square, plus T into C is the coupon interest, divided by 1 plus Y is the yield, power T. So we are calculating the present value, whole divided by price the bond into 1 plus Y square. Okay, so look at that. Please come down. The case is given below that itself. Price is 100, C is 15%, maturity is 5 years, yield is 18%. The yield is higher than the coupon rate. The price will fall naturally, 89.5. Okay. Now, how do we get that? 1 square plus 1 into 15. 1 square is a T square plus 1 into 15. 15 is the coupon interest payment, 15% of 100, whole divided by 1.18 power 1. That is for the yield, 1 plus Y power T. Then plus 2 square plus 2 into 15 divided by 1.18 power 2. Plus 3 square into 3 square plus, what is given is 3 square plus 2, not 3 square plus 2, 3 square plus 3, yes. 3 square plus 3 into 15 divided by 1.18 power 3. 4 square plus 4 into 15 divided by 1.18 power 4. 5 square into 5 square plus 5 into 15 divided by 1.18 power 5 whole divided by price, that is price 89.5 into 1 plus Y square, 1.18 power square. So you will get the answer is, can you please bring it down? Yeah, any clarification? That is 12.91. Any clarification with regard to the calculation part? Calculation part, convexity. Convexity is a second derivative, second order. The first order is duration, second order is the convexity. So curvature, we call it. In the curve, when you put the bond and the yield, the bond which is having higher duration will have a greater convexity. The bond which is having higher duration will have a greater convexity. The bond with this which is having higher convexity will have a higher price fluctuations. And the yield increases or the yield falls. Any clarification with regard to the calculation part? Calculation part, all of you understood? Okay, so the same convexity can be used for finding out the price fluctuations more accurately. We have seen earlier with the duration D star. I don't know how many of you remember that. D star is equal to minus modified duration into the changes in yield. We have seen that. So the same equation here we can use, but the price fluctuations can be estimated more effectively by using this convexity. So please come down. By using both duration and convexity, the effect of interest rate change on bond price can be estimated more accurately. The percentage of change in bond price is equal to minus modified duration into percentage of yield change plus percentage of 1 by 2 plus 1 by 2 of convexity into yield change square. So if there is 20% basis point change in yield, 20% basis points means 0.02%. Thus, we have seen 100 basis points means 1%. 100 basis points means 1%. 20% basis points means 0.2%. So, if there is a 20% basis point change in yield, what will be the percentage of change in bond price if the modified duration is 3.608? So look at the equation, minus 3.608, that is the modified duration, into 0.002 into percentage of yield change. 0.2%. 0.2% means 0.002 plus 1 by 2. 1 by 2 of 12.91. 12.91 is the convexity into 0.002 square, that is yield change square. So you will get minus 0.007178. So it will be minus 0.7178 percentage. So that is the, if there is change in 20% change, basis point change in yield, there will be 0.7178 percentage of change in price. So this kind of estimation is highly used by the bond portfolio manager to manage his